All right, let's do this. All right, we live? Yep. Okay, we are live. Okay, watch your language, everybody. We're live on the internet. All right, so we're going to finish up the problem solving section. I just got a couple more things to go over, then we can go play on computers. The last thing I haven't gone over yet are using proportions and similarity in figures. And so we'll take a look at those two things. Let's see, Denise, you said, what do you have a question about? Number 5 in the homework. Let's see, where's the homework? Okay. All right, so a friend has an average. Okay, so we'll get to the proportion in just a minute. Let's do this one first. Friend has an average, 79 average before the final exam. That includes everything but the final, which counts for 15% of the course grade. What's the best grade your friend can earn in the class? What's the minimum score your friend would need on the final to get 75%? Okay, let's steal some of that information into my sheet. I need a new page. It's okay. All right, so here's the information we have. Summarize it. So whenever I'm solving a problem, I always rewrite stuff. So we have a 79% average before the final. And the final counts for 15%. Okay, so a couple things to think of. Remember when we're working with percentages, sometimes it benefits us to think out of 100%. So if I consider that as far as the final is concerned, since the person hasn't taken the final yet, that means 100% minus 15% is what's available so far. So what does that give me, 85%? So that's what's gone on so far, okay? So then we have to consider, does the person have all 85 of those points? The answer is no, the person only has 79% of what's happened so far. So that means right now, this person has 79% of the available 85 percentage points that have happened in the class so far. And what does of usually mean in math? Multiply, yeah. So that means we want to know what is 79% of 85%. And so we whipped that out. Any calculators on the fly there? 67.15. So it's approximately 0.6715 as a decimal. And then we always want to read the fine print in the problem to type it in correctly. So what does this say here? It says, it doesn't say anything about how to type it. So what I usually do is I usually go one more place value than I'm given. So I would take it to one place. So would that be 67.2? And they're giving me the percent sign there. right? So I want to state it as a percentage, not as a decimal. That's another thing to pay attention to when you're doing these problems. All right, so next, what is the minimum score your friend would need on the final to earn 75? So clearly the person can't blow off the final, right? Because if they do, they get a 0. If they get a 0, that's they're going to get a 67.2% roughly. Okay, so
what is the best course grade that he can get?
mm-hmm. Yeah, so right now,
7.2 is the best course grade he can get?
if he doesn't take the final, yeah. Oh, am I answering a different question? Oh, let me think about this for a second. What is the best? Oh, okay. So sorry, for some reason I was assuming there that he wouldn't take the final. So I answered a different question. The best course grade he could get is if he got 100% on the final.
That's what I put.
Okay. Really? It didn't work? Okay, well, let's check it out. So let's go back to my worksheet here. So I answered a different question. I didn't read it carefully. So this is a good answer to some other question. And that happens. So let's see. The best course grade is going to happen if he gets 100% on the final, right? We all agree on that. All right. So then we're going to assume he gets 100% on the final. Okay. So now what we have is a weighted average. We talked about weighted averages in the previous course, so let's talk about them again here. So for a weighted average, there we go. For the first 85 points of the class available, this person got 79% of them. But there's more points available. How many more points are available? Well, 15 percentage points are available, right? So there's 15 more points are available. We're assuming the best possible scenario where he gets 100% of those 15 points. What's 100% as a decimal? 1. Yeah, 1.00, just 1. So I'm going to multiply by a 1 here. So that's my weighted average. Okay. And this whole thing is out of 100 points if we wanted to write that too. Why out of 100 points? Because I have 85 and 15 gives me the 100. That was a crappy highlight color. How did I get that? Choose yellow. So the 85 and the 15 are weights for the grades that he got in different parts of the course. So we got to perform this calculation. So basically, we're just going to add 15 more points on to the 67.2 that we already found. Right? So 67.2 plus 15 is what? 82.2. Okay. All right. If we divide by 100, it's going to make it 0.822 is the only difference here. So let's correct this here. So then the 67.2 plus the 15 extra percentage points, if he gets 100%, is going to give him 82.2% for a final grade. So that's the best this person can do, acing the final. So we want to figure out, well, what score would be possible so that he ends up with 75%. So that's where this weighted average thing comes in. So instead of assuming, like I'm doing here, that he's going to get 100%, that's my missing number. I don't know what that is yet. Okay, so I'm going to recopy most of this to another screen. Switch pens. Come on. Oops, shit, wrong button. There we go, that's the right button. So right now he has 79% of the 85 percentage points for the first part of the class. We want to know, what does he have to get on the final, what percent on the final for those remaining 15 points of the course, so that in the end, he gets a 75% in the class. So we got to run a little algebra on that sucker. So instead of plugging in all the numbers and doing arithmetic to get an answer, we have an unknown number here that we have to calculate. We could call that X if we want. So how do we solve this equation then? What would we do first? I'm thinking get rid of the denominator. Right, denominators are always a pain. So how do we get rid of the denominator of 100? Not, it's being divided now, so we multiply. We're going to, multiply both sides by 100. When we do that, it's going to cancel out the 100 on the left here and throw it on the right. So that's going to give me 0.79 times 85 plus, let's call it x, times 15 equals 100 times 0.75, which is 75. Now we already figured out that 0.79 times 85 is, what was it, 0.67, or in this case it'll be 67.15 if we go to its full accuracy. So I'm just going to clean this up again, 67.15 plus, a lot of people would write that as 15x. That's fine. What should I do next? Yeah, get rid of the 67. It's a positive number, so we're going to subtract it over to the other side. So I need to know what is 75 minus 67.15. There we go. So now I have 15x is equal to 7.85. Last step, divide by 15. No. So what is 7.85 divided by 15? It's going to be a little over 50%, I think. All right. So we're getting that x is about 53.3 to 1 decimal place. 52, I'm sorry, okay, I heard wrong. 52. And it was a repeating 3333333. Yeah, so repeating threes, that would make it exactly 52 1/3 if we cared about being exact. And sometimes we do and sometimes we don't. All right. You can leave it 52.3. Let's see what happens if we do. So let's check ourselves here. So to check ourselves, we just go back to the first part of the problem. We know he's got about 67.15% of the points for the course so far. We're calculating that if he gets 52.3% of the remaining 15 points, then he'll be around 75%. Okay, so what is 52.3 or 0.523 times 15? It's going to be 7 point something-ish. Is it 7.8? 7.845? Like that? Okay, and then we add those two suckers together, and what do we get? We get a 6, we get, oops, shit, not a 6, use the eraser, Gary. We're going to get 74.99, oh, that's going to round up because of the 5s. Oh, we're going to get 75, aren't we? It rounds up to 75. So we got it. Yeah, so the bottom line is the thing we need to figure this out is this equation up here. Come on, marker. There we go. That solves the second part. Plugging into here solves the first part and allows me to check my work. And so again, that's what's called a weighted average. And that'll pop up again in some other parts of the class. Let's see if it's right. Yes, let's do that. Okay, so what is the minimum score as a percentage? And so we are calculating 52.3. Oops, I'm not in the box. 52.3. And submit. Ooh, I got them right. Not bad. It's a good day. All right. All right. Let's get on to some proportions and similarity. New page. All right, so a proportion is when you have two fractions that equal each other. Like, for example, 1/2 is equal to 3/6. Right? To double check that a proportion is true, meaning the equal sign makes sense, we can cross multiply. 6 times 1 is 6, 2 times 3 is 6. Check, my proportion is true. We can use proportions for all kinds of things, like if there's a 30% off sale, that means I'm getting 30 out of 100 off. If I go into a store and there's an $85 item that I want to buy, this proportion will help calculate the amount off I get. Given that over here, I have the percent off. And how do we solve a proportion like this? Cross multiply. What was that? Cross multiply? Yes, we cross multiply. So we would cross multiply and then we can divide, would be one way to think about it. We'll look at it another way in a second. So that would give me 30 times the 85. And on the other side, I would have 100 box or 100x, whatever you want to call it. And then dividing by that 100 would finish it off. So the missing number is whatever 30 times 85. Oops. That didn't work out well there, Gary. Let's try that again. Over 100. And it was what, 2550? So that's one of the standard ways of doing proportions: cross multiply, divide. Do you always have to do that? Answer is no, not always. Sometimes there's a shortcut, especially if the missing number is on top. So I'm just going to redo that one and we'll try a different one. If I have the 30 over 100 equals, let's call it x over 85 this time. I could look at it just like a regular equation like I did that last one. I want that 85 to go away. So to get it out of the bottom, I just multiply both sides by 85. That way, on this side, they divide out. Number divided by itself is 1. And sometimes we call that canceling. It's really division. So now I know the answer x is whatever that works out to be right there, which we already calculated to be, what was it, 2550? So just a slightly different way to think about it. Algebraic instead of the old-fashioned kind of proportion way to do it. One thing I think is important when you're working with proportions, and I kind of skipped part of it here, is writing down what the numerator and denominator means. So for here, I did write at least what my numerator meant. Percent off, amount off. What would the denominator be here? What could I call that? Yeah, the whole price, original, something like that. Yeah. So whole or original. And the main reason I do that is just to remind myself, am I putting things in the right spot? Because every once in a while I throw a number in the wrong place and all hell breaks loose. So it's just little note reminders to me to make sure I'm doing my work right, especially if I look back at it later, so it'll make more sense to me. So that's always a good idea. All right, so some other places that we can use proportions besides percentages. Uh-oh, my slides get out of sync. We'll deal with that later. So, and this is with similar figures in geometry. And two figures are similar if they have the same shape. So, for example, all circles are similar. They all have the same shape. They're circles. Squares. All squares are similar. Some triangles are similar. They're only similar if they're exactly the same shape. So as far as triangles go, there's an example of a right triangle. I tried to make it so those two sides were each the same, 1 or 2 or whatever. I could make another right triangle that looks like that, and these two triangles are not similar because they don't have the same shape. To have the same shape, they'd have to have the same angles. Okay. I could make one similar to this one right here by drawing, say, a smaller version where maybe that's 1/2 and that's 1/2, and that's still a right angle. Because if these two sides are the same length, then that would mean that these two angles have to be the same too. Anybody remember how many degrees are inside of the triangle? All the angles add up to? 180, yeah. So if this one is a 90-degree angle, that means these guys have 90 to split, so they must be 45 each. And the same thing is going to be true for this angle here and that angle there. So if a triangle, if you have all the same angles, they're similar. They have the same shape. And here's the cool thing about figures that are similar. If they're similar, then side lengths are proportional. So I'll demonstrate that maybe with this pair right here. Page. So the moral here is that similar figures have proportional sides. Okay. So if I take the first triangle I drew, where that's a right angle, that's 1 unit, that's 1 unit. Did we look at the Pythagorean theorem last term? I don't think we did. I'm going to show it to you now anyway, just for fun. It's not part of this unit, but it's a cool thing to know. Pythagorean theorem says if you take the short sides of a right triangle, usually we call the short sides A and B. The longest side is always the one opposite the right angle, because that's the biggest angle. That's going to be called C. And the Pythagorean theorem says, what's that? Yeah, it's called the hypotenuse too. Yeah, so the hypotenuse is always the longest side. And for some reason, we give it the letter C. And if I take the lengths of each of those short sides and square them and then add them up, Pythagorean theorem says that's always equal to the square of the long side. Okay. So if I apply that to this triangle right here, I don't know what that is yet, but I do know that I have a 1 squared plus a 1 squared on this side. Well, that's just 1 plus 1, which is 2. So the missing number is some number such that when I square it, I get 2. Well, that's the opposite of squaring something. What's the opposite of squaring? Square root, yeah. So this missing side has to be the square root of 2. Has to be the square root of 2. And what the similar figures and proportional sides means is that if I draw another version of this that's just smaller, say, where this is a half and that's a half, since I halved each of these sides, this diagonal has to be half of the big one too. So it has to be 1/2 of the square root of 2. It's got to be. So I'm going to... Correct. It's 1.4 something, something, something. It's a crazy number. Yeah. It's about 1.4. So let's just double check that that's true using the Pythagorean theorem. So I'm just using an idea from similar triangles. So here's one way to write it with proportions. I could say that like the bottom leg, let's see, no, I don't want to write it that way. I want to write it hypotenuse first. So if I take the hypotenuse and divide by the length of the bottom leg, doesn't matter which triangle I pick, if they're similar, it's going to be the same answer. So on the big triangle, that means take the square root of 2 and divide by 1. On the little triangle, let's make believe I don't know what its diagonal is, but I do know the bottom is a half. And so if I solve this proportion for that missing number, that will confirm the number I stated here. Now, sometimes you can just look and it's obvious. Half, half. Sometimes it's not obvious and you got to work it out. That's why I'm showing this way here. So let's just double check. If I want to get rid of the 1/2 so I leave my question mark alone, what should I do? Times both sides by 1/2. Yeah. So I'll multiply this side by 1/2. I'll multiply that side by 1/2. Now let's bring that to a new screen. It's getting a little messy here. So I have square root of 2 over 1 equals, let's say, x over 1/2. If I multiply both sides by 1/2, a number divided by itself cancels out to be 1, right? So I'm left with 1x on this side, which we usually just call x. On the other side, isn't dividing by 1 pretty lame? Right, nothing happens. So all I'm left with is 1/2 times the square root of 2, which is what I predicted it was going to be earlier. Right? So usually with similar figures, if we know the original figure and part of what we want to turn it into, we can figure out any other parts. And I'll show you another good use of this in a sec. Double check with the Pythagorean theorem. So here's my little triangle again. It's 1/2 by 1/2. Let's call this side C, because that's usually what we call the long side. Pythagorean theorem says if you take the leg and square it and add that to the other leg squared, that will give you the long side squared. All right, help me out. 1/2 squared means 1/2 times 1/2. What's that? 1/2 times 1/2 of 1/2 would be 1/4. Okay, but then you're going to add them up. Okay, you're way ahead of me. Slow down, slow down. It's Friday. I'm slow. Okay, so that's going to be 1/4 plus 1/4. In the end, 1/4 plus 1/4 is 1/2. So I'm looking for a number whose square is 1/2. How do I get rid of the square? Square root. So the missing number has to be equal to the square root of 1/2. Oh shit, wait, that's a different number than I got here. Whip out your calculators. Let's check this out. That's the square root of 1/2? 0.707-ish. Okay, so what happens if you take the square root of 2 and then cut it in half? Calculate the square root of 2, 1.4, blah, blah, blah. Divide it by 2, what do you get? Is it the same number or a different number?
I think it's the same number.
Did you?
Well, closer because it was 0.7 and the other one.
1.4-ish. Yeah, if you double this, you're going to get about 1.4. But just double check. You know, it is. Yeah. So I'm just going to make sure here. Google can tell me too. Yeah. So the Pythagorean theorem works with the proportionality. Just double check in a spreadsheet or in a Google kind of calculator. If you type SQRT parentheses and then the number you want the square root of, it'll give you that 1.41-ish. Let's blow that up. If I divide that by 2, I'm going to get what Anthony said was the square root of 1/2, 0.707-ish. Double check that. What is the square root of 0.5? 0.707-ish. It's the same number, just two different ways to get it. Question though, which was easier, solving the proportion or whipping out the Pythagorean theorem? Was easier? This was easier than that?
I like the Pythagorean theorem.
Oh shit.
Used to what I do.
Okay. So my opinion is that this bottom one is wicked cool, but it's way more work than the top one here. Yeah. So we can't always use the Pythagorean theorem. Sometimes it works, sometimes it doesn't. Triangles, right triangles, it works. The cool thing about the proportions is it works in a lot more places. It works in a lot more places. So I'm going to give you a different example. So any shaped triangle it would work on. I'm going to give an example with some rectangles. So not all rectangles are the same shape. Oops.
You always have to have a 90.
Use the Pythagorean theorem, you have to have a 90-degree angle. Yep. If it's not there, you can't use it. You have to find some other way to check things out. All right. So here's a rectangle. Is that the same shape as this rectangle? Right, not all rectangles are similar, but some are. Okay, so these guys are not similar. All right, so I'm going to draw another rectangle, and it may not be as accurate as I want it to be because I'm just kind of guessing. Let's see, let's go that far and this far. I think this is about right. A common rectangle when dealing with like photograph kind of stuff is 640 by 480. Okay. When you're working with photographs, you use what's called an aspect ratio. So the aspect ratio here would be 640 divided by 480. It's a fraction. Whenever I see a fraction, I'm dying to reduce it. How about you guys? Yeah, so let's reduce this fraction. So let me see, 10 goes in the top and bottom, right? Anthony's reaching for his fraction reducing calculator. He's going to beat us to it. So I could say this is 64 over 48. And then I could cut top and bottom in half, right? So let's see, half of 64 is 32, half of 48 is 24. Cut it in half again. Oh, 8 goes into both of these. Yeah, it still does. Okay, so 8 goes into 32, what, 4 times? And 8 goes into 24 3 times. Well, that's cool. An aspect ratio of 640 by 480 is the same as an aspect ratio of 4 to 3. Yeah, so there's lots of different versions. So an aspect ratio of 640 by 480 is the same as an aspect ratio of 4 to 3. It's the same as an aspect ratio of like Brady said, 8 to 6. Okay. They're all equal. Whenever I make two fractions equal, what's that called? Starts with a P. Proportion, yeah, that's a proportion. Okay, so what do I care about aspect ratios and proportions? Well, we live in a very digital age, and people are always posting pictures of interesting and stupid shit they do online. And sometimes they resize those images. Have you ever seen an image online somewhere that somebody distorted where they look wider or thinner than they're supposed to be? That's because they messed up the aspect ratio. When I take a picture with my camera, I'm trying to remember, it's huge. My camera takes pictures that are something like, is it 4,000 by 2,000 roughly pixels? Roughly, I'll have to look it up.
Do you use your camera, or do you guys share the camera, or do you use the phone?
I use my phone camera. My wife has a fancy digital camera. I used to until my daughter dropped it. Yeah, my phone is a really good one. So it's somewhere in that ballpark. I can't remember exactly what it is. I should have looked that up beforehand. Anyway, the problem with that is that's a huge image, right? It's way bigger than the pixels available on the screen in front of me here. So it saves more data than it can display. It probably doesn't say on your camera anywhere. You would have to take a picture, put it in a photo editing app, and then and the photo editing app will tell you how many pixels wide, how many pixels tall the image is. So that's an enormous picture. And a lot of times when you, like, does anybody ever text pictures from their phone? Right, we do that all the time. Often when you do that, the texting app on your phone reduces the image size to be sent because the original image is too damn big. But it reduces it in such a way that the aspect ratio remains constant, meaning it stays the same shape. And that's what aspect ratio is about, maintaining shape. Okay. So let's suppose that I have an image that is 2,000, I don't know, 650 pixels wide. So let's say this is width over height. I want to know what would the height have to be so that it stays in that common 4:3 aspect ratio. And the bottom line is different phones have different aspect ratios for the pictures they take. It all depends on how it was programmed and the hardware that's in the phone. So yours might be in a 4:3 ratio, it might not. It just kind of depends. And then sometimes, can anyone do a panoramic shot on their phone? Panoramic shot ain't 4:3, right? It's going to be like maybe 6:3 or 7:3 or 8:3 or something like that, depending on how wide the panorama is. So whip a little math out on this. Tell me what you think the height would have to be so that a picture that's 2,650 pixels wide has the right aspect ratio. So do a quick calculation here. I'm going to look up my phone's parameters. It won't be on the phone. That's why I'm going to the internet to look. I can't remember what kind of phone I have. It's a Nexus something or other, 4 or 5, Nexus 5, I think. That's how it works. Yep, can't keep up. Okay, so let's see. What does it say about my phone? Camera. It does not say here. Let's go back and search again. What do I want to know? Camera resolution. No, that's not right, is it? I thought it was way bigger than that. Oh, that's the wrong phone. Try one more time. That's the right phone. Really? I could have sworn it was bigger than that. Okay, I'm going to send one to myself to double check here. Anyone get a number on that? Oh. Oops, I lost my calculator now.
So the width and height is 4,000 and 2,000?
No. We're going with a width of 2,650. We want to know what the height's going to be to go with that. Yep. So we can stay proportionate. It's Friday. Anyone get around? Don't tell them. Okay. All right. What do you think, Juan? You're not sure? Did you get near 2,000? No? Uh-oh. Okay, we better do that one together. Okay, here's my photo. And let's download it. Uh-oh. Did I do it wrong? It's got to be less than 2,000, right? Because it's got to be 4 to 3. The denominator's got to be smaller. Okay, let's try again. Let's go download, save.
Yes, 1325.
You got 1325? Oh, shit, did I do something wrong? 2650.
2,000 times
Hmm.
2650 divided by 4,000,
No,
right?
no, it's 4 to 3. 4 to 3. We're doing this rectangle right here. Solve that proportion.
Oh man, I don't know what I'm doing.
Yeah. This is extraneous information at the top. So I got 1,987.5. I will confirm that in just a sec. All right, my image, okay. That's what I thought. Yep. All right, so let's double check that, and then I will show you. We'll try another one. So let's see, to solve this, because the missing number is in the bottom, I have to cross multiply and then divide. So I'm going to have to calculate 2650 times 3. On the other side, I get 4 times question mark. To finish that off, remember we cross multiply and then divide? That cancels the 4 out because the number divided by itself is 1. So my missing number is whatever 3/4 of 2650 is. And I believe it's 1,987.5, is that right? Is what I calculated there. All right, we're going to try another one like this. So one way to think about this, if I was going to print an image in a 4-inch by 3-inch frame, and there were 2,650 pixels across in that image, there would have to be 1,988 roughly pixels high in order to fit in a 4 by 3 frame, is what we just calculated. Okay? Those two rectangles have the same exact shape, whether we call it pixels or inches. All right, let's try another one. So I just looked up, I sent myself a picture from my phone, and I'll show you guys the picture. It's not a very special picture. This is a picture of the big pile of dirt behind the softball field. And that's my dog's butt. All right, and according to this, the bottom corner of this, so this is a free editor called Pixlr.com. It's really cool if you like editing photos. It's easy to use. It says my image is 3,264 pixels by 2,448 pixels. So let's see what kind of aspect ratio that is. So let's see, can I remember those numbers? 3,264 and then 2,448. So 3,264 over 2,448. So whip that into your calculator and see what it gives you when you do the division. You right there, Brady? Don't break anything. Is it? It's 4/3. You get 1.33333. Yeah. So if you have a regular calculator, it's going to give you something like that, which is 1 1/3. and then 1 times 3 plus 1 gives me that that's 4/3. So my phone does do a 4:3 aspect ratio, which is pretty common, but not every phone does that. Now that is a ginormous image. It's more pixels, I think, than are available on the screen. Let me check. You guys know how to check your screen resolution on a computer? To check your screen resolution, right click on the desktop and then choose screen resolution. How about that? It says the screen resolution here is 1,280 by 1,024. So my image has a lot more pixels than can fit on this screen. This is 1,280 by 1,024. So suppose I wanted to resize the image so it fit perfectly on the screen. Is 1,284 divided by, 1,280 divided by 1,024 a 4:3 ratio? It's 5:4, so it's a 5:4 ratio. That's another common ratio you see out there. There's tons of aspect ratios depending on the device we're using, right? Whether it's a certain monitor or an iPod or a Google tablet or whatever. Okay, so here's what we're going to do with my aspect ratio. We are going to rewrite this. Let's get rid of this stuff. Oops, I got part of it. Oh, come here. Get over. There you go. So I want to resize this image so that it's 1,280 pixels wide. I want to know what the height would have to be so that it would be just wide enough for the screen I have here for my display. So whip out your calculator, see if you can bust this out, get me an answer for that height. And remember, this is width over height for each of these. So we're going to do a little cross multiply divide. I'll fill in some steps for fun. Oops, wrong digit. So that would be the final calculation that's going to lead to the correct height. Anyone got a number for that? 960? Okay, so my screen is taller than the image proportionally. 960? All right, about the same, you guess. Let's double check. So I'm going to take the 1280 times 2448 divided by 3264. Ah, okay. Yeah. And it's rounded to 960, right? It wasn't exactly, yeah. So it's approximately 960. So I should put a wavy equal sign here. The missing number is about 960. It's a little smaller than that, right? Yeah, 959.7-ish. You got 960 even? Did I mistype a number? 32. Oh, I mistyped a number. Darn it. Gotta do it again. I divided by 3265. It's exactly 960? Okay, so I was full of shit, sorry. All right, I guess my fingers were too big for these buttons. So it's exactly 960. Okay, I'm a big liar sometimes, I know. Yeah, and the bottom line is resizing image is important. I just demonstrate something here. A lot of programs tried to help you so you don't have to worry about screwing that up. But we are really good at finding ways to screw things up. Like I know I am. So in this image right here, say I want to use this on some site and the site says this image is too big, you can't use it. So I'd have to go and reduce it somewhere. So there's an image menu in this program, and I can say change the image size. And notice it's got a button that says constrain proportions. What that does is I plug in a number, it calculates the other number for me. So if I come in here and I type, what was our number, 1280 for the width, it says, oh yeah, your height should be 960. If you ditch the constrain proportions button though, so let me image.
So that's when you actually,
So if I ditch that and I come over here and I type the 1280, and then I just say, hey, I want it to be the same height as my computer. So that was the 1024, and I type 1024, and I hit OK. I've now messed up the image. So if I zoom in on it, it's hard to tell I messed it up, but my dog is actually skinnier than he's supposed to be. He looks pretty good right there.
he just lost it.
My vet said he needed to lose weight. Now I just send her this picture. Oops. Hey, he's doing fine. Look at that. Oops, shit, I keep hitting the wrong button. Escape. There we go. So it doesn't look too bad on this image because I changed it basically from a 4:3 aspect ratio to a 5:4 aspect ratio. If a person was in there, the person would look a bit thinner than they're supposed to. Right? I would look deathly thin. So that would not be good. All right, so that's it for now. That's kind of the last thing in this problem-solving unit I needed to go over with you. We have another half an hour of class, so I would recommend going into the lab and getting some shit done. Or since it's such a beautiful sunny day, you could procrastinate. I wouldn't recommend procrastinating any further, sir.
Can you look and see if I got all that stuff done? 'Cause if there's something
Yeah.
missing for this week, I'll-
All right, those of you online in the future, hello, give me a call or send me an email if you need any help. Bye-bye.